Bismillahirrahmanirrahim. In a sequence of independent tests of integrated circuits, each circuit is rejected with a probability P. Let Y equal the number of tests up to and including the first test that results in a reject. Y is the number of tests up to and including the first test that results in a reject, right? So part A, what is the PMF, probability mass function of Y? Part B, if there is a 0.2 probability of a reject, that is P is equal to 0.2, what is the probability mass function of Y? So Y is a random variable which is the number of tests up to and including the first reject. So to model the number of trials up to and including a first success, we use geometric distribution, right, to model the number of trials up to and including the first success. We use geometric distribution or geometric random variable. So in this case, this random variable Y is a geometric random variable, right? And the PMF of a random variable Y in this case is given as Py of Y is, the parameter is P into 1 minus P raised to the power Y minus 1, right? And Y is from 1, 2 and 3 and so on, and this is 0 otherwise, right? So so the random variable Y here is a geometric random variable, and the distribution is given by this, right? So here P is the probability of first success of a success in a trial, and P is between where P is greater than or equal to 0 and less than or equal to 1, and the range of the random variable Y is 1, 2, 3 and so on. So if you note that if we put in the values of Y 1, 2, 3, so let's see what happens. So if Y is 1, right? So if Y is 1, so this term is Y, 1 minus 1 is 0, so this disappears, this becomes 1, and we are left with only P, right? And when Y is equal to 2, if you put 2 here, so we get P into 1 minus P, right? P into 1 minus P. And if we put Y is equal to 3, then we get P into 1 minus P raised to the power 3 minus 1, which is 1 minus P square. So if we go on like this and we put Y is equal to for example some value n, so then we get P into 1 minus P raised to the power n minus 1. So if we see that this is a geometric sequence, right? It's a geometric sequence with common ratio 1 minus P, right? So this is why this is called a geometric distribution, because the successive values, they result in a geometric sequence with common ratio 1 minus P. So this results in a geometric sequence. So it deals with the kind of problems, for example, uh, what is the probability that a first success occurs at xth trial or yth trial? What is the probability that a first success occurs at yth trial? So to calculate this kind of probability, we use the geometric distribution. And note that in our given case, this first reject is our first success, right? So when you get a reject, we treat it as a success as described here. So this solves us the part A of our given problem. Now to the part B. For part B, we're given that the probability of a reject P is equal to 0.2. So simply substitute the value of 0.2 in our this distribution, right? And we can rewrite it. P is equal to 0.2 and 1 minus P is simply 0.8, right? So this becomes Py of y is equal to P is 0.2 and 1 minus P is 0.8, and that is y raised to the power minus 1 for y is equal to 1, 2 and 3 and so on, and this is 0 otherwise. And if we plot this distribution, we take y, for example, along this axis, and suppose this is a 0, this is 10, suppose, and this is 20, and at 1 the probability is 0.2, right? 0.2 here, and with successive values the successive probabilities will follow along this, for example, curve. So next value will be like this and so on, like this, and this is how the successive values will give the probabilities of the successive value will be for the values of y. So this concludes our solution to the given problem.